Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer C, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So a mass of 0.9 kilograms is suspended from the lower end of a light spring of stiffness 80 newtons per meter. When the mass is displaced vertically and released, it undergoes vertical oscillations of a small amplitude. What is the frequency of the oscillations? So we've got a spring and a mass, and when we pull the mass down and release it, it's going to oscillate upwards and downwards about an equilibrium point. Well, there's a couple of equations which we're going to use to solve this problem. And the first one is that the time period for a spring mass system is equal to 2 pi multiplied by the square root of the mass over the spring constant. And the other one that's going to be very useful is the frequency of any system is equal to 1 over the time period. So let's start off with this first equation to find what the time period is. And the time period is going to be equal to 2 pi multiplied by the mass, which we're given as 0.9, over the spring constant, which is 80 newtons per meter, and we need to square root both of those. If I put that into the calculator, we get a time period of 0.67 seconds. And I can use this time period in this equation to find the frequency. And into my calculator, and I get an answer of 1.5 Hertz. Answer C. If you found this useful, please press the like button. All comments will be welcome, and I hope you'll share and watch more in the series.